then winding, then insulations, then tank. So by using these data, now we draw the drawing in AutoCAD. I hope everybody have installed this AutoCAD, any version like 2016, 17, any version. So parallel at the same times you can also do it. So how to start? How to start the drawing? So the when you open the AutoCAD software, so this is the first page will get open. So here you can click on templates, select ACAD.dwt, select this form. Okay, now the page will get open. So before starting the drawing, first thing is what you need to set the units, because all units, the design data we obtained for drawing is all units dimensions are in only. So therefore we set the units in millimeter. Type unit, okay, select units. Now set the unit in, here it is in inches. Now set this is in millimeter. Okay. So select precision for decimal is like point after decimal how many zeros you want. You can select that one. It is for also degrees. Now select this for millimeters. Okay. Okay. Then now page setup. Okay. What is the page setup? In that page we want to draw the drawing. For page setup, in the command line, just type limits. Okay. Limits. Now it is showing that specify lower left corner. So lower left corner is nothing but a origin. Okay, x coordinate and y coordinates are 0 0 at the lower left corner. So here just enter. Now specify upper right corner dimension. Okay, so how much length of page you want, you can specify. Since our diagrams are in we have the diagrams in larger dimensions, we have like 1000 millimeters. So we set the upper right corner like 5000 comma 5000, enter. So we have set the page. Firstly, to start the drawing, set units, then set the limits of the page. Okay, size of the page, that is actually. Okay, now start the drawing. So here what is the data? Dimension of magnetic frame, you can see. Diameter of a circumcircle. Okay, so there is a core. Over the core there is a circle. That circle is called as circumcircle. Okay, and that diameter is 240 mm. Okay, 240 mm. Now click on circle command, choose diameter. Okay, now set this diameter to 240. So move this circle in this limit. Okay, so this is the circle. So little bit I'll move here, enter. So this is what cruciform circle diameter, that is 240 mm. Now we have to draw the core in between this circle, that is three-step core. Okay, and in the last session I have told you how to draw the three-step core. You can see this is a three-step core, and how to draw the these are called as the stampings: larger stamping, lower stamping. And for the larger stamping, how to draw the size of the larger stamping? It is 0.9 into d. D is what? Diameter of the cruciform circle. So 0.9 into d is how much? Go to calculator and check how much is the 0.9 d. So 0.9 into diameter is how much? 240 mm. So this is 260. Okay. Now here the length here the stamping larger size is the length is 260. Now here draw 260 line, make ortho on 260, enter. Okay. Now again you can see the lower stamping. Okay, you can see it is 0.4 in for 0.42 into D. So 0.42 into D is how much? 0.42 into 240. So this is 100.8 it is. So D is how much it is? 240. Okay, 100.8. Let me check how much is D. So D is 240. Okay, fine. So 0.4 into D is 100.8. Now again go take a line command. Now here from this 100 point into 8. And now again 260. Down this one. Now make a center line. Now go to copy command, copy this one. Okay, choose from the center as a base point. Okay, now we can make ortho of, enter. Okay, now again what I do, I will rotate this one in a vertical way, because you can see from the diagram. So here the larger stamping is in vertical position. Okay, I will rotate this one. Go to rotate command, select the object, enter, rotate from any point, make ortho on. Okay, again delete the center line, copy command, place the center line. So from the center only I can place the object, copy, enter. So from the center make ortho of. Okay, now this is what a larger stamping is in vertical position and horizontal position. There is one more stamping. Okay, that is 0.7 into 0.7 into D. So how much is 0.7 into D? 0.7 into 240. Again 168. It is 168. Okay, so again we draw a square, make ortho on 168, 168. Now join this one. I will draw a center line. Okay, now go to copy command, copy this whole object, enter. So make again ortho off, so we can place this at center. Okay, and now delete these objects. Now delete the unnecessary lines. Go to trim command, select trim, enter here only. Now so this is what 3-step core. This is what 3-step core. Fine. So this 3-step score is what? This is a rule. Okay, always larger stamping is always it is 90% of the diameter of the process circumcircle, and the second lowest one is already 70% of the diameter, and the very smallest one for 3-step is it is 42% of the diameter. So this is how we draw the three-step code. Okay. Now what? Again go to the table. Now go to table. Now we are drawing. Firstly, what we are doing? We are drawing the top view. Okay, we are drawing the plan of the transformer. That is the top view. Okay, for if you see the transformer from the top view, so only we can see a core and the windings in a radial direction. Okay, windings. So now what we have to draw the LV winding and HV winding. Now from the table, now you can see there is a insulation. So after this core drawing, next is what there is a insulation. Now you can see oil duct between core and LV former. Okay, core and LV former, oil duct is there. Okay, so we have to draw a circle. Okay, of 5 mm. Go to drawing. See here, offset. Okay, specify 5 mm, enter. Now click this object and click outside. Okay, so this is what this one. This is a duct for oil between a core and LV former. LV former is what, on the former on which we wound a winding, that is what is LV former. There is oil duct. Okay, next what is there after oil duct? Now you can say there is an insulating cylinder between oil duct and LV winding. There is an insulating cylinder, and the width of that insulating cylinder is 3 mm. Again, go to offset, set 3 mm, enter. Now select the outer circle and place here. So this is a insulating cylinder. This is a insulating cylinder. Next, what is there after the insulating cylinder? Again, there is an oil duct between insulating cylinder and LV winding, and the width of that oil duct is 5 mm. Okay. Again, go to offset, set to it to 5 mm, enter. Now select the outer circle and place outside. Okay. So first I will save this drawing as a three-phase core type transformer. Okay. So now this is what all about the insulation between the core and the LV winding. There is oil duct, and then there is the insulating cylinder. Again, there is oil duct. Now we have to place the insulating LV winding. Okay, and you can see from the table the radial width of the winding. So you can see radial width of the winding for LV. You can see it is 29 mm. Okay, radial width under LV it is 29 mm. Again, go to offset, set it to 29, enter. Now click the outer circle and place outside. So this is LV winding. Okay, and LV winding, see again what? Again go to here. Now you can see LV windings are it is a coil. Okay, and here how many layers are there in a coil? You can see there are 8 layers, 4 layers. Okay, there are 2 layers. Okay, and in 2 layers the conductors are arranged radially. 4 conductors are arranged. Okay, and between 4 conductors there is again an insulation of 1.8. Fine. Now what is the size of the conductor? So the size of the conductor for LV winding, so it is how much? It is 3.4 into 16.4. Okay, 16.4 are arranged in vertical way and 3.4 in radial way. Okay, and how many layers are there in LV winding? There are 2 layers. Each layer consists of 4 number of conductors. Okay, so the total it is 29. Okay, and we have 8 conductors here where, and the width of the conductor it is 3.4. Okay, so go to again drawing. Okay, set offset to 3.4, enter. Okay, now this is LV winding. This is the radial width of the LV winding. Now click this circle, place here. Okay, so this is what? One conductor. Again click this one, place. There is a four conductors. So 1, 2, 3. Again, click here. And between there are two layers. In one layer, there are four conductors in a radial way. Okay. Now again, between two layers, we have 1.1 insulation is there. Now click outer circle, place inside. Now you can see this is LB winding. Okay. So this is a insulation between two layers, and we have four conductors in one layer and four conductors in other layer. Okay. So this is LB winding. Now coming to the HV winding. Again go to the table and check. Okay. So HV winding, again its radial width is 29. So there is an insulation between LB winding and HV winding. And what is the width of the insulation? You can see. So there is a oil duct between HV and LV and HV former of 5 mm. Now again go to offset, click offset and set it to 5 mm. Enter, click the outer circle and place. Okay. Now again go to table and see after the oil duct what is there. Again there is a thickness of HV insulating cylinder of 6 mm. Okay, go to offset, set to 6, enter, click the outer circle and place outside. So this is what insulating cylinder. Now again what we have, again LB duct between HV former and LB winding is 5 mm. Again go to offset, set 5, enter, now click outside and place here. Okay, so this is the insulation between LV winding and HV winding. So there is a oil duct, then there is an insulating cylinder, again there is an oil duct. Now draw the LV winding. So what is the radial width of the LV winding? So you can see from the table it is 29 mm. Again go to offset, set it to 29, enter, click the outer circle and place. Okay. So this is radial width of LV winding. Again what? LV winding consists of how many conductors and how many layers? So you can see from this figure. So you can see there are 10 conductors. Okay, arranged in radially, and whose width is 2.9. Okay. Now again go to offset, set 2.9, enter, click the outer circle and place. There are 10 conductors which are arranged radially. If we count these, so we can get 10 numbers. So this is HV winding. So this is HV winding. Okay. Now what? This is for one leg. So in three-phase core type transformer, we have 3 legs. Fine. So what we do? We'll copy this one and place. Okay. So before copying this object, I want to trim certain portion. Enter. So for trimming the portion, I'm saying this is like a reference line. Again enter, the line will get choose. Now see, when you see the transformer from the top view, okay, so we can see the windings this side only, because the top one it is covered by the yoke. Okay, that is nothing but a core. So we'll trim this line. So go to trim. Okay, enter. Now we'll trim each line. Okay, we have to trim each line. Now trim all the lines. Okay. And now we draw a line from here. And what is the length of the yoke? You have to see. Okay, length of the yoke, because the top There is the cores are arranged in vertical way and yoke is in horizontal way. When you see the transformer from the top view, so we can only see the yoke. And what is the length of the yoke? You can see it is 1076. Okay. Now choose line command. So from this make ortho on. So it is 1076. Enter. Okay. Now we delete these lines. Okay. Uh, Now we'll mirror this whole part. Okay. So we delete. Okay. Now we mirror this whole part. We can delete this one also. Okay. Now go to mirror command. Copy this whole object. Enter. Now click at the center point only because we want exactly at equal distance at that side. Click at the center point. Click below. Okay. Now you can see the other leg winding is also created. Now the center part is what? For doing that one, we again copy this whole object, enter from the center point, we place here. Okay, we delete. We delete this line. Now from here we'll draw a line for trimming purpose. Enter. Okay. Now again what I do? Oh sorry. Control Z. Okay. I have to trim here. Go to line command, extend these lines. This is for reference for trimming only. Okay. Now go to trim command, enter. Now trim each line. Now you can trim, you can delete these lines. We join this point because we want a center point to copy it. Okay. Now copy the whole object, enter, choose from the center line, place it at the center. Okay. Now we join all the points. Enter. If you enter again, the previous command will get repeat. Take the line command, join the points. Again, join all these points. So there is a gap. fill these gaps. So this is what a transformer, three-phase transformer. When you see from the top, okay. Now see, always the core of a transformer, like that is nothing but a yoke and core. These are not made with a solid material. These are made with the stampings. Okay, these stampings are pressed together to form the complete core structure. So for that purpose, what we do, we'll go hatching this core here. So here you can see this is the hatching command. Okay, click this hatching command. Select this one. Now select ANSI 13. Select this. Okay. Now click the angle to 45. Set it to 45. Okay. Now see, you can see the hatching is not solid. So for that purpose, now set this line. Its scale. You can see it is a scale. Set this is to 5 and check. Again it is more only. Now set this is to 10. So this is in vertical direction. Control Z. Again I'll go to hatch. Select this. Set this angle to 135. Okay. Set scale to like 50. Set it to 50. Enter. Now you can see. Okay. Sorry. I think here it is open. Somewhere it is. See, there is a line here. Join this line. Enter. Now again, go to hatching. Set this to 135 and set this to 50 or 100. Enter. Now click the points. Enter. Again, the line has not joined over here. I think somewhere here. First, I will undo. Okay. And I'll join these points. So zoom it and join these points. And here also, one more it is open. Again, we will try hatching. Select this one. Set angle to 135. Set this to like 50. Enter. Okay, enter. So this is the transformer from the top view. This is the transformer from the top view. Next thing is what? We'll draw a front elevation of a transformer. Front elevation. When we see the transformer from the front view, and we are seeing the cross-sectional view of the transformer, that is from the front view. Okay. For that purpose, okay, simply extend these lines. Enter. Okay. Now from this point, what is the length of the yoke you have given? It is 1076. 1076. Enter. This is the length of the yoke. Okay. Now what is the total length of the core plus yoke? Okay. So you can see length of the yoke is 1076. Height of the yoke is 200. Okay. So there is a core leg. Okay. Upon the core leg there is a yoke is placed. Okay. And the yoke height is 200 at the top side, 200 at the bottom side. Okay. So total it is 700 plus 200, 200. So how much it is? Uh, 700 plus 200, 200 is 900,000. So go to line command. Okay. Set this line to 1100. Enter. Okay. So I'll copy this, move this whole object little bit upside. Enter. Okay. Again from this it is 1076. Enter. Join. It's fine. Okay. Now we extend these lines again up to here. Enter. Okay. Now what is the width of the core? You can see again from the table, width of the core is 216. Width of the core is 216. Okay. Now go to trim command, enter. You will delete all these lines. Enter. Again there are lines over here. You delete these lines also. Simply click the lines and delete. Now what is the again trim, enter. You delete this. Okay. And what is the width of the core? It is given the table, it is 216. Go to offset 216, enter. Okay. Now select this line and place here. Again select this line and place here. Okay. Okay. Then height of the yoke, how much it is given? So height of the yoke it is given is, you can see from the table, height of the yoke it is given is 200. Okay. Again go to offset. Okay. 200, enter. Click this line, place here. Again from the bottom, click this line and place. Okay. Next is what? Join these points. Because when you see the transformer from the front view, the core will look like this one. Okay. Now go to trim, enter. Now we trim these extra lines. Okay. Again from the bottom side. Enter. Now you can delete these lines by selecting it. Delete. Okay. Now we'll draw a center line. Okay. Now we'll make a mirror of these lines. Okay, select these two lines, enter, click this enter, and place here. Okay, again go to trim, enter, delete the extra lines. Okay, now again from this point draw a line over here. Okay, again I will do a mirror. So before doing the mirror, what I do, I will first join these two corner points. Okay, now trim, enter. Now we can trim these lines. Now we mirror. So we are mirroring this line into this one. Select the lines, enter. So always for mirroring, always choose a center middle point. So it will place exactly here. Okay, exactly here. Now what? Uh, delete the lines. Now the center leg. How to draw the center leg? We know that for the center leg, uh, distance between the center to center distance between the course is 430. Okay, center to center distance between the course is 430. Fine. Uh, so from this line, click the center point here. Again, the center core is also width is 216. Okay, and 216 divided by 2 is how much? 216 divided by 2. So it is 108. Okay. Now go to offset, set to 108, enter. Yes. Okay. Now we join all these lines. You enter it, it will repeat the previous command only. Okay. Now, now again, what will copy these lines at the center only. We'll copy these lines. Okay. And for that, delete this line and this also. Okay. Now mirror, take mirror command, click these lines. For mirroring, we want a center line. So join these 2 points. Okay. Go to mirror. Select all the lines. Enter. Now from the center, okay, mirror it. Okay. Now we'll again go to trim. Enter. Again trim. I will delete this one also. Enter. Now take line command. From here, make ortho off. Join this point. Okay. Again line command. Okay. Trim. Trim this one. And what are the lines we have to trim? This one, this one, this one. Again, take the line command, join these points. Now extend, trim, enter. Now this is the core when you see from the front view. So this is how core look like. Okay. So this is three-step core. So this is middle one, middle limb, left side and right side. Next part is now coming to the winding diagram. Uh, Windings, when we see the windings from the front view. Okay. First, always upon the core there is always a LV winding. On the LV winding we have a HV winding. Now we'll draw the LV winding. Now go to table. Now see. For LV winding, what is the radial width of the LV winding? It is 29. Okay. So I'll draw here 29. Enter. And what is the height? What is the height axial length of the winding? For LV it is 541.2. 541.2 here. So make ortho on 541. Enter. So this side 29. Enter. Okay. Yes. So this is LV winding. Okay. And LV winding, before the between the LV winding and core we have an insulation. Okay, we have an insulation. So after the LV winding we have an insulation of, so you can see from the table, after the LV winding we have an insulation of 5. Then there is oil duct of 5 mm. Then there is an insulation cylinder. Then there is a 5 mm. So go to offset, set to 5. Enter. This is 5. Now there is an insulating cylinder that is of 3 mm width. Set to 3. Select this line and place here. Enter. Okay. Again go to offset. Again there is a oil duct of 5 mm. Offset to 5 mm and select this line and place here. Okay. So this is a oil duct. Okay. Now this is a oil duct. Fine. Now we join these lines. So separately, why I'm drawing the LV winding is because, so later on I'll copy the LV winding and place exactly at the center of the each core legs. Okay. Okay. And how many layers are there in LV winding? How many layers are there in LV winding? Again, go to that table. See, the layers are like 8 layers, and between the 8 layers we have 1.8 thickness. Okay, this is what in radial way. And what about the uh, excel number of turns? How many are there? So you can see uh, how many number of turns are there. So there are 12 turns in one turn. So there are 22 turns, 11 XLE. So there are 11 turns are XLE. Okay, because there are 22 turns, because we have arranged the LV winding in 2 layers. So each layer contains 11 turns, right? So 11 turns. Okay. So before that, the width of the LV winding conductors in each layer is 3.4. Go to offset, set to 3.4, enter. Okay. Now this line takes here how many? 4 conductors. 1, 2, 3, and 4. Okay. How many 4 are there? 1, 2, 3. So 3 only. No, 4. Now from this side, 4. Okay, so this is LV binding layers. Now, how many turns are there? There are 11 turns. Fine. And what is the width of the each turn? So it is 49.49.2 one turn. It is 49.2 here. Fine. Uh, okay. 49.2 set to 49.2. So go to offset 49.2, enter. Now select this line. Let's see. So we have to join these lines, and now we trim it. Okay, we'll go to offset 49.2, enter. Now select this whole line and place here. Wait a minute. I think the lines have got placed in cross way. So once again, I will place the line, delete, enter. Now we'll go to offset. It is 3.4, enter. So make sure that ortho is off. If ortho is on, if ortho is off, the lines will. How many conductors are? One, two, three, four. One, two, three, four. Now after four conductors, we have a insulation of 1.8. Okay. Again, four conductors, 3.4, 2, 3, and 4. Enter. Now we join the points. So if ortho is off, the lines will get placed not at equal distance. Okay. Now the turn height, it is 49.2. So go to offset, set to 49.2, enter. Okay, so this is LV winding. Now you can see this is what in between layers. Okay, these are the four conductors. So if you want to hatch the parts, let's see, solid. Okay, so closed path is now showing. Okay, if it is red dots are coming, type REGEN. Okay, regen all. Okay, hatching is not doing properly. You can do go to hatching, go to option, set this to maximum tolerance to maximum tolerance. Okay, set that to maximum tolerance, and let's see at this time hatching will be done or not. Mhm. So it is saying there is no close path. It's close path only fine. Forget about it one. Type REGEN. Okay. So this is LV winding. So place the LV winding, okay, at the center. Okay. I will take a mirror copy of this one. Select whole LV winding. Enter. Now place anywhere. So this is mirror copy of the LV winding. Now uh, we'll extend this line, this line. Make ortho on. Okay. Enter. We're going these points. Go to trim. Trim this line and this line. This line. And I can again go to trim. Trim this line. Enter. Now I can delete. Sorry. Again trim these lines also. Enter. Save. Trim. Now we can place the early winding here. Now copy this early winding. Okay. Enter. So from this center point, choose this one. Make ortho of. So at the center point, place the LV winding. Place the LV winding. Okay. Uh, you can see what is the distance from here. So we can make a line directly there. So this is 12. This is okay. Now take line and join. I hope everybody also doing parallelly. So this is LV winding I have placed here. Okay. So what I do, I will draw a line of 12 mm, that is make offset of 12 mm. Enter. Okay, even same 12 for this LV winding. Join these points. Okay, again copy, enter from the center point, place here, and one more is here, enter. Now copy every winding of this face, copy it, place here. So this is LV winding front view. Okay, and this is the LV winding front view. Next is HV winding. So again, same thing. Delete, save this. H winding. What is the height of the H winding? See from the table. So height of the H winding, XL length of the H winding. So it is 700. So this is 700. Height of the XL length of the H winding is 700. So in that 700, this is exact. In that 700, there is also a insulation part is there. In that 700, there is also a insulation part because the length of the core is also 700. So from the calculation, you can see. So where is HP winding? So XL length of the winding. So this is what high voltage. XL length of the winding. Total XL length is 70 centimeter. So this is nothing but a 700. Okay. So this is what out of this one. What are they? Okay. So out of this one, there is a total length is of the HV winding is 700 mm. In that 700 mm, there is also insulation is there. So you can see using 6 spacer in between the coils. This is in between the coils, 6 spacer. Okay. Then there is a gunmetal end ring at the top of the winding of 3 Okay. So what we do, we draw a LV winding of make ortho on 700, enter, and again radial width is also for LV winding is 29 only. Okay, 29, 700, enter. Okay, fine. Out of this 700, so there is a end gunmetal end ring at the top of the winding of 3 and there is a slackness of 0.8 centimeter. That is uh, uh, 0.8 means in it is 8 So here in gunmetal end ring it is 30 centimeter. That is 30 Okay. So at the top there is a space of 8 After that there is a end gunmetal ring of 30 Okay. Now we place that one, and also there is an end insulation and bracing of 10.4 centimeter. Okay, 10.4 centimeter, that is 100 Fine. Firstly, there is at the top 8 space is there. Okay, go to offset, set to 8 enter, select and place. This is the 8 space. This is nothing but a slackness. Okay, and after that, what is there? Gunmetal end ring at the top of the winding, that is 3 Okay, 3 centimeter, that is a 30 30, enter, 30. Okay, then what is there? We have an end insulation and bracing at the top and bottom of 10.4 centimeter, that is nothing but 100.4 104. Okay, uh, 104, enter. and from the bottom also, and from the bottom also. Fine. Now this is LB, HV radial width, and but this is HV is what after the LB winding, and between LB and HV winding we have insulation. Again, go to table and check what is the insulation between LB and HV. So there is oil duct of 5 mm. Okay, now go to offset, set it to 5 mm, enter. Okay, then we have a 6 mm thickness of the insulation. Go to offset, set to 6, enter. Okay, then again lastly what we have, again we have a oil duct between HV forward and HV winding. Okay, go to offset, 5, enter. Now cover this points. Okay, now coming to the size of the coils or conductors in the HV winding, you can see from this diagram. So this is what at 31.6. Okay, we have to offset it, and the layers of the layer width is 2.9. Okay, set to 2.9, enter. So delete this line. Firstly I will join this one only. Okay, because that line I have to offset. Okay, go to offset, it is 2.9, enter. Oh, place over here. So 2.9, it is conductor size in radial direction. Okay, now again what height, it is 31.6. Go to offset, 31.6, enter. These are nothing but a 1 ton. So this is HP 1. I'll join this line also. Now I'll mirror this HP winding because I have to place the H winding on both the legs. So I'll place point here. Okay, now copy this HP winding, enter from the center line, make ortho of, So this is HV binding. So center of this line, on this side, see the center point, and so we have placed the HV binding. Okay. Now we'll place on the other side. Copy, enter, select from the center point, with the center point to check that one. Okay. With the center point, enter. So this is what HV one did. So these are nothing but the insulation. So these boxes are nothing but the insulation here. Okay. Uh, so when you see the HV winding, so join these lines. Now this is the front elevation of the transformer. So you can mention in a text also. Choose multi-line. Select first point. Now you can mention this as three-phase four-type transformer. So you want to increase the font, you can increase the font to like 100. So this is three-phase four-type transformer. So this one is called as front elevation. This is called as front elevation, and this is called as this is a plan. This is called as plan, or that or a top view, and this is the front elevation. So if you want to mention the dimensions also, we can mention there. So here, go to linear. So total height, including the yoke. Now here you can't see the text and arrow, and for that go to annotation, click standard, manage dimension style. Okay, create new one, copy of standard, continue. Okay, symbols and arrows. Now set the size of the symbol and arrow. Like I'll set it to 30, and even text to 30. Okay, close. Now select this one, right click, dimension style. Okay, I'll take as copy of standard. Now we can see we have increased the text size and arrow size. So this is one done. Now length of the code, this point and this point. So you I have taken the line, this point, this point. So this is 700. Okay, this is the length of the code. Now length of the yoke. So this is 1076. This is the length of the yoke. Now width of the core. So width of the core is what? This point and this point. This point and this point. So this is 260. This is the width of the core. Okay. Now width of the yoke, width of the yoke, okay, this point make ortho on, and take from here. So this is 200. So width of the core is 200. Now you want to mention the diameter also. You can mention the outside diameter of the LV winding. It is 440. Okay. So inside diameter of HV winding. Sorry, it is HV winding. So this is 356. If you want to mention the inside diameter of LV winding and inside diameter of inside and outside diameter of LV winding. Okay. So this is how we can mention. So this is the front. This is the front elevation, and this is the top elevation. Okay. So this is what design so now it is 6:30. Quickly we'll move to the drawing of the DC machine. Okay. So tank is what, the tank is also given the dimension. For the tank, they are given the dimension. In the same way, we can draw the tank. Okay, tank is what, this houses the whole core and winding. That is a tank. Okay, and also this is oil type transformer. Okay, so cooling and insulating is oil here. So the length, height, width, and uh, length is also given of the tank. Height is given, width is given. So by taking this, we can draw the tank also. So this is the main part. So core and winding. So next we'll move to drawing of a DC machine. Okay, drawing of a DC machine. Now again, for a drawing of a DC machine, okay, you save this one. Okay, go to start. Start. Go to templates. Click ACD CAD. Okay. Again, we repeat same thing. Set units to millimeters. Okay. Okay. Now page limit. Left corner it is 00 only. Enter. Now we'll set the right corner to 5000, comma 5000. Enter. So the page limits also not here. Okay. So if you want to take the print here, so there is a print option here. Plot. Okay. So select, you want to convert into PDF, select DWG to PDF, or you can convert AutoCAD PDF. So we'll select DWG to PDF. It is drawing AutoCAD drawing into PDF. Okay. Now this is a paper size. So here the paper size they will use A4 size. So select as window. Okay. Now make a window on this whole diagram. Click set to center plot. Okay. Now, okay. Now save it. Uh, so this is how we can take the print. Okay. So this is three-phase copper transformer, top view and front view. Okay. So next we'll quickly move to DC machine. And for a DC machine, we have the table. So this is the table for the DC machine. Okay. Now main dimension, armature. So armature diameter is 720 mm. take circle diameter with 720 mm. Okay. Uh, 720 mm, I think. So again, what I do will move this circle to here. Okay. So this is armature. Next, this is armature diameter is 720 mm. Then what next? Air gap. So after the armature, we have a air gap. So on the armature, we have a slots. Let first we'll draw the slots here. So how to draw the slots? Where is the slot dimension? Slot dimension is what it is, 38 mm into 9 mm. So 38 is in vertical way, 9 mm is in horizontal way. So okay, now we'll draw a line from the center to here. Okay, we'll offset. So 9 is in horizontal way, that is the width of the slot. So go to offset, set 9, enter. Now offset here. So this is nothing but a width. Again, what we join these 2 points. Okay. Now go to offset. Now set, that is a height of the slot, that is 38. Enter. Select this point and place. Mm, 1 second. How much? Offset. So it is 30. Oh, sorry. Slot width is what? It is 9 mm. So we need to offset 4.5. So slot width is what it is, 9 mm. So we need to offset 4.5 on each side. Okay, offset 4.5, enter. So we'll offset here and here. Delete this line. Again, we'll join these 2 points. Enter. We go to offset 38, enter. Select this line and place. Okay. Now again, trim. Delete. Now, how many slots are there? How many slots are there? I can see from the table. See how many slots are there. It is given here. Number of slots. So number of slots are on the table. It is not mentioned. So number of slots. Go to the design, slot design. So there it is given. And you can see design of slot. So how many number of slots are there? Dimension of slot, size of the conductor. So number of slots, you can see it is 88. So number of slots are 88. Now how to make 88 slots? So for that there is a special command, that is array. So in that array, choose polar array. Okay. Now select the object. Okay. Enter. Choose a center point for always for a polar array. Center point. Okay. So now the number of slots placed are 6 here, but we want 88 slots. So here items are 6 here. Now we will edit this is to 88. enter. So we can paste 88 slots. Delete. Okay. So this is one slot. Now we join these ones. So how to make array here? Once again I'll say. So again, what this is a slot. This is a teeth. Okay. So this line I want to place on every teeth here. Now go for array, polar array. Select this line. Okay. Enter. Always for a polar array, choose the center of the point here. So this is center of the point is circle. So six item every time six item get placed here, but we want 88 item. Edit this to 88. Enter. Oh, sorry, center point is not placed properly. Array. Enter. So we need to select the center point. Sorry, we'll draw a circle once again. Okay. Then we can get the center point. So what is the diameter of the armature? Diameter of the armature is 720. The diameter of the armature is 720, right? So this is 720. So take a diameter. Otherwise, what we do, we join a lines from this point, make ortho on and to this point. Now we can get the center. Okay. Now go for polar array, click, enter. No, even now also the center point is not getting. So we'll undo everything. Okay. Now we have a center point. So for reference, we will draw one circle simply of one any diameter. So I think center point is one. I think center is there. So we'll draw a circle. Not getting the center point here. Sorry, supply has gone. I connected through mobile. Okay, once again I'll present the screen. Okay, can you see this AutoCAD page? Yes.
Yes, sir, it's visible.
Okay,
Yes, sir,
fine.
it's visible.
Okay, fine. Now see, to draw this is how we draw the slots. Okay. Now we delete. Now we join the line. Enter. Now go to array. Select. Enter. Center point. Okay. Again go to array. Enter. This is not a center line. On right. Once again, I will draw the whole thing. Wait. Center point we have reached. Firstly, we'll draw a diameter of 720 mm. Enter. Now we join this line. Okay. Now go to offset of 4.5 because width of the slot is 9 mm. This side 4.5 and this side 4.5. Enter. Okay. Now join these two lines at the top side. Go to offset of 38 because height of the slot is 38. Okay. Enter. Now go to trim command. Enter. Now delete all lines. Now delete this middle one also. Okay. Now go to array. Select the object. Enter. From the center. Okay. Now it is got 6 placed. Now we want slots of number 88. Okay. 88 we have placed. Now delete this circle. So before deleting the circle, there is a air gap is also there. So length of the air gap is what it is 3.5 mm. So there is an air gap always between a stator and the rotor, and the length of that one is 3.5 mm. So first I'll draw that circle. So set the offset to 3.5. Enter. Okay. Now I will delete this line, this circle, and this line because this is a slot. Now we join these two lines. This is nothing but a T. Again go to polar array, select this line, enter the midpoint, and we want 88 number. Enter. Yes. So now we have placed the T. So these are the number of slots. These are the number of slots. And the slots are there is a wedge is placed at the top side. Okay, so because the conductors does not fall out of these slots, so there is a wedge placed at the top of the every slots. Okay, and the shape of this wedge is like this. Mm. So the space for wedge is 3 mm. Okay, space for wedge is 3 mm. Uh, so for that purpose, it is a here from here it is 3, enter, and from here it is make ortho on. So from here it is 3. Okay. Now make ortho of. Okay, now trim. So I'm making a wedge here. Okay, again join these two lines. Now I will mirror this line to this side. Enter, center point, mirror. Delete this line, trim, enter. Okay. Now go to polar array, select all object, go to enter. So always for a polar array, center is the reference point. So 6 numbers are placed. So we want 88. So 88 numbers of wedges are placed. Fine. Now height of the pole. Now the air gap is done. The armature is also done, and these are the slots. And in these slots we have a armature winding. Now to draw the poles, main poles. Now, for that one field system, height of the pole is 220 mm. So go to offset 220, enter, select this line, this outer circle, and place. Okay. Now from this point to this point, we'll join. Now coming to the width of the pole. What is the width of the pole? Width of the pole is 196. Okay, 196. And to draw the width of the pole, uh, 196 divided by 2 is how much? So 196 divided by 2. So this is 98. Now offset to 98, enter, select this line, offset here and offset to here. Now the extra lines we have to trim. Now next one is what? Now thickness of the poles is 40 mm. Thickness of the poles is 40 mm. And how to draw the thickness of the pole? Before that one, so this pole pitch. How much is the pole pitch? Or pole arc. So see here, thickness of the poles is 40 mm. Height of the this one is pole arc. We have calculated pole arc as 40 degree. So to draw 40 degree, see, because there is a pole, below the pole we have a pole shoe, and how much the pole is covering the armature, that is nothing but a pole pitch. And from that pole pitch we have calculated the pole arc, and pole arc we got as 40 degree. So select line from the center. Okay, tap. So angle is how much? It is 40 degree. Okay. Now 40 is from this one. Okay. So how much angle is? So angle pole arc is 40 degree. 40 degree means, so from this line we want a 40 degree. So we need to set it to 60 degrees. Then only we can get. Now 40 means 20 here and 20 here. Okay. 20 uh, this side and 20 this side. So select line. So 90 minus 20 is how much? It is 70. Set to 70. Enter. Now we'll mirror this line from the center point. Make ortho on. Okay. Now this is what? Pole R. Now this is what? Pole R. Now width of the pole shoe. Width of the pole shoe. So what we do, from this point we'll join this point. Now width, thickness of the pole shoe is 40 mm. So go to offset 40, enter this line to 40 mm. Okay. Now we join the lines. Next is trim the unwanted lines. Trim, enter. Delete these lines. Again go to trim, enter. Okay. Now draw a vertical line. So make ortho on. Enter. Now again trim. Now delete this line. Now this is a pole. This is a pole. This is a main field pole. Now depth of the yoke. Okay. Yoke depth is how much? So field system, width of the pole, thickness. Uh, yoke is how much? Magnetic separate. Depth of the yoke is 80 mm. Okay. Now go to offset. Set to 80. Enter. Now this is yoke. Now this is yoke. Fine. Now again, how many number of poles are there? There is 6 number of poles. So go to array, select pole, enter, choose a center point, enter. Now there are 6 number of main poles. There are six number of main poles. Fine. Next, there are also a interpoles. Okay, and we'll draw interpole. Interpole axial length is 160, height is 218, width of the poles is 36. So it is 218, 36. Okay. Now interpoles are placed here. Interpoles are placed here. So for six poles, what is the angle? Uh, so every pole 360 divided by 6. How much it is? 360 divided by 6. So it is 60 degree. So draw a line with 60 degree. Make ortho of, so 60 means here what, this is 90 degrees. Okay, this is 90 degrees, this is 0, so here it is 60. Now tap, make it to 60, enter. So this is the line. Okay. uh, Now width of the pole is how much? Width of the interpole is how much? Height width of the pole so is 36. So here so width is, so uh, the angle we can make here is it is 60, 60 minus 90 is how much? 40. And line from this point with an angle of 40, and 36 divided by 2 is how much? Uh, Sorry, it is not 40 degrees. So we can set to 30. Okay. So how much the width of the pole is how much? Width of the pole is 36. 36 divided by 2. 36 divided by 2. So this is 18. Okay. Here only I will draw the interpole. Uh, Height of the interpole is 218 and width is 36. Make ortho on 218 and width is 36. 218 and width is 218, 36, 218 and okay. Now I will rotate this to like 60 degrees from this point. Make ortho of So set this angle to 60 degrees. Okay, so 60 degrees this way. 360, set this to 300. Rotate. So angle of this one. So to place the interpole, first we'll place the windings, then we'll place the interpoles. First we'll place the winding of the main pole. So main pole winding, later we can place the interpole. So main pole winding is what? Uh, Armature winding. So armature winding is 15.4 into 1.8. Okay, and axial length of the pole, width of the pole, series schematic circuit, depth of the armature core, depth of the pole, various winding. So shunt field winding, cross sectional, number of turns, this one, diameter of the conductor, the number of layers, depth of the winding is 44.5. Depth of the winding is 44.5. So depth of the winding is 44.5, and height of that one, height of the field winding, height of the field winding is 112. So this is 44.5 depth and height is 112. Total line, uh, height is 112. Draw a line of 112 mm, and width of the 44.5, 44.5, enter 112. So this is what field. Now we can place this field winding here. So first, see, there is a shunt field winding. Since this is a DC compound generator, it consists of series winding as well as shunt winding. Series winding as well as shunt winding. So we'll place first series winding, then shunt winding. Now series winding is, what is a series winding? So series winding, number of turns are 2. What is the series winding depth and all that? Number of turns are two only. So here number of turns are 2. So it is 15 into 20. So 20, 20, 40. Okay, 40 into 15. Or you can make 30 into 30, 30, then 20. So number of turns are 2. There are no layers. So series winding. So here this is 20, and here it is 30, again 20, and so this is series winding. This is shunt winding. Now we can place the windings here. How to place the windings? I'll extend this line to here. There is an insulation between these windings, so I can set to 10. Now I'll move this series one. Okay. I'll again take a mirror of this one. Now I'll move from this point over here. Make ortho off and snap off. So there is no insertion, so directly we are fixing the series one. Okay. So to fixing this one, so better will offset this line to 10. We'll draw a line. So I'll mirror this one directly. Go to mirror, select whole object, enter, choose a center point, enter, make snap on, ortho on. So this is a series binding. Okay. Now there is a insulation at the bottom side and at the front, top and bottom. I will trim the extra lines. And there is a insulation here also. Trim. And there is a insulation at the top. So this is what shunt binding and field binding. Again we mirror this insulation part also. Mirror, enter, choose a center. So this is the winding on the main course. Now array for whole winding. Go to array, select every point, enter, go to center. So this is the windings on the main course. Windings on the main course. The smaller one is what series winding, and here it is a shunt winding, and whose depth and width is given in the table. So you can say from the table. Series winding number of turns here it is only 2. So this 15 into 20. This itself is the dimension of the series winding. Okay, and here shunt is also given for a shunt. Uh, Depth of the winding is given 44.5 and height is 112. So we have drawn the windings of this. So if you want to hatch, you can hatch the windings. So go to hatch, select ANSI, set the angle to 135 and the scale you can set to some 5. No, so 5 is smaller. So I'll set this to some 20. So this is 20. Right? And now I will again go to array, select these wordings, enter, midpoint, enter. So this is the sand wording. So now there is also a armature. There is also a commutator. Uh, Bhargav, can I take some more 10 minutes extra? Okay,
Yes, sir, you can take.
see, I'll just show the diagram directly. How we have drawn. Lastly, how to make the tops. There is eye at the top of the machine. Enter. Now I move this one up to off. Yes. Enter. Now coming to the commutator. Commutator segments. How many commutator segments are there, and what is the commutator diameter? It is. Now go to commutator diameter. This is 500. Go to circle diameter. Diameter to set it is to 500 mm. Okay, this is commutator. And there is a computer segments. Okay, there is a computer segments, and computer segments. This is 4.46, and computer segment 4.46. The angle we are getting for this one is 1.022. 1.022. And how many computer segments are there? The computer segments are, it is 352. So if we go to the design, so computer segments are, so this is 352. It is given. uh, so you can see from that computer segments it is 350. Where is that one? This one. Computer segments. So length of the commutator, and the commutator segments are 352. Okay. So for 352, we need to draw the commutator segments. Okay. And the angle of that one is 1.022. 1.022. So now, so firstly I will draw commutator outside only, then I will place. So 500 This is for computer segments. So this insert circle for computer segments. Now we'll draw a reference line, enter, and angle of 1.022. Okay, angle of 1.022, or you can directly go for polar array. You can directly go for polar array of 352 computer segments. Now trim, enter this one. Now go to polar array, select this line, enter. Press enter. So this is the center. Okay, and how many computer segments we have? It is 352. So this is the commutator segments. This is the commutator segments. Fine. Now we'll place this commutator inside here. Okay. On the commutators we have brushes also, because brushes are to collect the current from the commutator, and what is the brush width and all that. Thickness of the brush is 12.5, width is 20, height is 32. So thickness of the brush is 12.5, width is 20. Okay, and height is 32. Uh, so it is 12.5. Okay, I'll draw the brush. Uh, what is the dimension? So it is width is 20, height is 32. Ortho on 20, it is 32. So this is the brush. Okay. So this brush will be placed over the commutator. Now copy, enter. So from the center line, we'll place the brush over the commutator segment. So before placing, simply first we'll extend the line. Now we copy this brush. Make ortho of, enter. So this is the brush. Again, how many brushes are there? Go to table. Height is given, number of brushes. Number of brushes are 14. If you see the design, so number of brushes are 14. So again, go to polar array, select the brush object, enter, select the center point, and it is 14. So this is the commutator. Now we copy commutator from the center point. We'll copy the image and we'll place over the center. So this is the commutator. Okay, this is a commutator, and at the center we have a shaft. Okay, and for a shaft we have a lock, and to draw the lock, we'll go to offset and offset it to like 20. Again, we draw a line here, make auto on, enter, bring, no, delete this. So this is the shaft. This is the shaft. So for some designator, only main poles are there, enter poles are not there. Uh, then there is a basement. So I have drawn this DC machine already here, so we can look at. So this DC machine. So this is what these are, ducts are the ventilating duct. This is a shaft, and there is a interpole also. We have an interpole. Here I have drawn the shunt field first, then there is a series field. So but actually series field is there. After that we have a shunt field. So this is a DC machine front view, that is a cross sectional view. That is a cross sectional view. So if you want to take the print, go to plot, continuous single, okay, go to display, take window, select the object and take DWG to plot, take center and OK and save it. So this is what DC motion. So this is what DC motion. Okay. So this is what, how to design a machine, obtain the physical dimensions of the machine. Okay, for the given specification, then draw that one in AutoCAD. So this is what about the DC machine, and this is a transfer part. So anybody have any questions, queries regarding how to draw the drawings in AutoCAD? Yes, Bhargav, anybody have any doubt, they can ask. Any queries?
Yeah, please ask your queries in chat box or turn on your mic to ask.
Turn on your mic, you can ask, or you can chat, you can ask your questions and queries in the chat box. So this CAD is very simple. If you practice this one, this will be very, very easy. Starting, you can take the time. So once you are perfect, so you can draw these diagrams within half an hour. All that. So anybody have any questions? Yes.
Okay, okay, so we assume there are no doubts. And thank you
Yes.
so much for your valuable time. Here we have a small token of appreciation for you.
So can I stop my presentation, Bhargav?
Yes, sir. Sir, is my screen visible?
Yes. Yes. Yes.
Yes.
Thank you, Bhargav.
Thank you,
And,
sir, for valuable.
okay, thank you very much for giving this opportunity. Hope the participants have utilized this session very well. And thank you, thank you from the bottom of my heart to IEEE branch, student branch, CUK. And thank you to all.
Yeah. Thank you, sir, for your informative session. I hope all the participants have received a lot of information from you. Posting the feedback form link in the chat box and asking the participants to fill it. Please fill the feedback form.
Okay, Margot, then shall I leave
Yes,
the
yes.
meeting?
Thank,
Okay,
no, sir.
thank you all. Thank you.
Thanking everybody once again and closing the session today.